Hey, Vsauce Jameson here. Let's take a blast to the past. 1919, New York. There was a great disturbance in the force, as if several voices had cried in terror and were suddenly silenced. What was the source of this disturbance? A giant molasses explosion. A large molasses storage tank burst, and molasses rushed out into the streets at an estimated 35 miles per hour, wreaking havoc. The company responsible tried to shift the blame to an explosion caused by anarchists. But the truth of the matter is this: the fault was the poor engineering and aberration of the company. That's enough history for now. Let's pass the baton off to my math analyst, Logan Cable.
I think that's the right answer. So here's the problem. There is a 90 by 90 cylindrical tank. This tank is filled to the top with molasses. We need to calculate the total force exerted on the base of the cylinder. So what do we know? We know that the weight density of molasses is 100 pounds per feet cubed. Comparing it to water, which has a weight density of 62.4 pounds per feet cubed, you can see that molasses is much heavier. We also know that pressure is equal to the weight density times the height or depth of the liquid. And since the depth is 90 feet, we can calculate the pressure to be 9,000 pounds per feet squared. What even is pressure? Pressure is a measure of how much force is exerted on a square unit of area. Put it simply, pressure is total force divided by area. Note that if you increase the area, you also decrease the pressure. The figure on the left has much more pressure than the figure on the right, even though the forces are the same. And the reason is because the figure on the right has the force distributed on a much larger area. Let's go to the thought bubble real quick. Okay. How's that, Brent?
Very painful.
Alright, let's put the platform on. How's that, Brent?
Way better.
Oh, really? Okay, remove the platform. Remove it right now. There we go. Thanks, Thought Bubble. So what we learned from that is that if you increase the area for a force to be applied to, you decrease the pressure. Now let's put that into application. Since pressure is a measure of force distributed per unit area, this means that to get total force, we need to multiply pressure times area, also known as F is equal to A times P. Think of it as adding a bunch of little tiny units of pressure. From this equation we get that the total force exerted on the bottom of the base is 57,225,526 pounds. Yikes. Now that we know how much force is applied to the bottom, let's calculate how much force is applied to the sides of the cylinder. This is the main reason the cylindrical tank practically exploded. We want to calculate the force exerted on the bottom foot-wide band of the tank wall. Now how are we supposed to do this when the force exerted varies depending on whatever height a portion of the band is at? The answer is slicing. We need to create an equation for an infinitely small band and then add all of the bands. Let's create an equation using the equations that we already know. Combining equations, we get that force is equal to the weight density times the height times the area. Area is equal to 2 pi RH. Wait a second, what is H? Since we are cutting the 1 foot band into many slices and adding all the slices up, our H is going to be an infinitely small number and as such can be represented by dy. So our new equation is 9,000 pi y dy. Now all we need to do is take an integral of the equation we just found from 89 to 90, since we are doing the bottom foot band. We end up getting that a force of 2,530,553 pounds is exerted on the bottom foot band alone. It's no wonder the cylindrical tank couldn't hold up. Moral of the story is, do calculus before you do anything. It saves lives.
Remember, such a tragic story could have ended differently if the engineer had a simple understanding of calculus. So always remember, when you're sitting in your math class, lives are at stake. Always remember, calc saves lives.
Hello, welcome to Cooking with Brent. Today we're gonna make some molasses. So first you take the special ingredient number 1 and you pour some of it in there. Then you're gonna take a little bit less of special ingredient number 2 and you're gonna pour it in there. And then you're gonna whisk it around for a bit.
Siéntame chi tu fa fa. Tu vuoi vivere alla moda, ma se bevi whisky and soda.
And now you have some ready-to-use molasses. That's it for Cooking with Brent for today.